Hello and welcome back. Today we will keep working on our drum machine, adding a subdivision feature, drum sounds, and a step sequencer feature. Open the file you saved from last tutorial. Go to the File menu, open Recent, and select the name you gave to the file we are working on. Let's add some further control to the tempo of our patcher. Some metronomes have the option to make a click on the beat, but also on the subdivision of the beat. Create a new object and type radio group. Create a number box and connect it to the radio group's outlet. You'll see that the radio group will output 0 or a 1 depending on which button is on. You can change the parameters of the radio group to add more buttons, but we will be okay with these two for now. Create a new object and type /1. This is a division object, and the argument 1 will divide our tempo in milliseconds by 1. We will use the radio group to change the division's argument and divide the beat by either 1 or 2. Because the radio group output can be 0, if we connect it directly to the division, we will generate a division by 0, which will make our tempo to collapse when the operation is triggered. You can actually try it, nothing will explode or anything. The easy fix to that is to add 1 to the radio group's output. So we need to create a new object and write +1. Connect the number box with the output from the radio group to the addition object. Create another number box to check the output of the addition object. This is not strictly necessary, but is a good way to check that everything is working fine and to troubleshoot if needed. Connect the number box with the output of the addition to the right inlet of the division object. Connect the number box with the time in milliseconds to the left inlet of the division. Now, this is important. As it is right now, our patcher won't work really well. That is because the right inlet of the division is a cold inlet, meaning that it only sets the argument of that object without producing any output. The new division will only happen if you change the speed in BPM we have connected to the left inlet, or hot inlet, of our division. We can make an adjustment to fix that. Create a new bang object. Connect it to the outlet of your radio group, so it will bang every time you trigger this object. Connect the bang to the left inlet of the division. This will cause the bang to trigger an output every time you use the radio group. There is another catch to it. No big deal, but it's something you need to know because it can make the difference in more complex patchers. Because computers can do only one thing at a time, the order of operations of max objects is from right to left. This means that when you click on the radio group, it first sends the signal to the number box on the right and then to the bang on the left. For the division to be triggered right, your bang object needs to be on the left of the number box, so it will trigger the division after the argument has changed. Otherwise, the bang will happen before the argument has changed, and when the argument changes, nothing will trigger the new operation. Another option is to use a trigger object. Create a new object and type T space B space I for bang and integer. This object will output those data in order from right to left, but it will make the location of the objects irrelevant. Connect the left outlet of the trigger to your bang and the right outlet to the number box. Connect the radio group to the trigger. Delete unnecessary wiring. Now your operation will be triggered in the correct order regardless of the position of the objects. Now connect the outlet of the division object to the right inlet of Metro and the right inlet of Make Note, and delete unnecessary wires. So far, you have quite an interesting patcher, but it only produces one pitch in a piano sound. We actually want it to produce more than one sound and we want drum sounds. Let's edit our note object. Remember, you can use the help files to learn more about each object and its arguments. When you put an argument to the note out object, you are selecting a MIDI port in case you have set up several of them, and or a MIDI channel. If we add the argument 10, it will be established that the output data will go through channel 10, which is the standard channel for percussion in all programs that use MIDI standard protocol. So your MIDI driver will play these sounds as drum sounds. In the percussion channel, every number is used for a specific hit of drum. To learn about other numbers and the sound they produce, you can try different numbers in the message box, or substitute a number box for your message box. That way you can see what sounds you want to use for your drum machine. Now we want to create an object that allows us to shift between sounds. There are several ways of doing that. There are actually several ways of doing anything in Max. It depends on what you want. We will use another radio group. Create a new object and type radio group. We need to add more buttons to it, so select it and go to the inspector. Search for the parameter number of items and write the number of sounds you would like to have. I think 5 is a reasonable number. We will now use an object called uMenu, which stores a list of elements you want to be able to choose from. Create an object and type uMenu. To populate the uMenu, you need to select it and go to the inspector. Go to Menu Items and click on Edit. A small window will open. There you have to write the MIDI numbers you want to use separated by commas. I chose the numbers 27, 28, 30, 32, and 54. You can use different numbers or list them in a different order. Now connect the radio group to the uMenu. Lock the patcher and see what happens when you click on the radio group. Create a message box to populate with the MIDI notes from the uMenu. We want to populate the message, not to output it, so we will connect the second outlet from the uMenu to the right or cold inlet of the message box. We use the second outlet of the uMenu because it outputs the actual content of the item, as opposed to the first outlet which outputs the index number of each item. Now connect the bang coming from your Metro to the left inlet of the message and connect the message box to the make note. Now when you turn the toggle on, you should be able to shift sounds using the radio group. By now, your patcher is probably looking a bit crowded, so you can take a minute to organize it better. We need to make some room for the step sequencer. I'll be back with mine looking a little bit better as well. A drum machine works basically as a step sequencer, which means that it goes from one step to the next at the speed of the established beat in a constant loop. So far, we only have one step, so we want to include more of those. We will copy and paste that part of our patcher several times, but before we do that, we want to add all of the features we need in each step, so we don't have to add them later to each step separately. Let's add the possibility to activate or deactivate each individual step. Let's add a new object and type gate. The gate will let the signal go through or not depending on its state. We will use a toggle to open or close the gate. The toggle will be connected to the left inlet of the gate. Connect the message to the gate's second inlet. Now you will be able to turn each step on and off. When the toggle is off, the signal will go through the step, but the message will not make it to the make note. So instead of a beat, you will have a rest in that specific step. To be able to know which step is sounding, we will add a bang to each step. Add a bang object and place it below the radio group for the step. Connect the message outlet to the bang's inlet. Now let's copy that whole chunk of the patcher and paste it 7 more times. So you have 8 steps for your drum machine. In Max, to copy and paste is like in any other software. You select the object or group of objects and press Ctrl or Command C to copy and Ctrl or Command V to paste. We're almost done, but we need to figure out a way of sending our beat to each of our steps one at a time. We will use 2 objects for that. We need first a counter to count the beats for us. Create a new object and type counter space 7. This object will count 8 numbers from 0 to 7. Create a select object by putting a new object and typing SEL space 0 space 1 space 2 and so on up to 7. Select will receive the counter's numbers and output a bang through each individual outlet when each of its arguments is matched. Create a number box in between these 2 objects, so the counter is on top and the select object is on the bottom, and connect them. Connect the bang from your Metro to the left inlet of your counter. Connect the outlets of the select object from left to right to each of the message objects in your steps by the left inlet. Connect the gates to the make node object. Your drum machine is functional now. Save your progress. On the next video, we will tweak our patch a bit to make it easier to use and nice looking. Thanks for watching.